Hello everyone, my name is Kevin Boris. I'm joined as ever by Bob McQueen, and welcome to our first of our series of Smart Mobility video masterclasses. And today we're going to be talking about the application of advanced transport analytics in the 21st century. We've been joined by Gadi Snay. Gadi is Vice President of Product for Mobility Insight in Israel. Gadi, welcome to the show.
Thank you very much, Kevin. Pleasure being here.
Well, thank you for taking the time to join us. For those watching who may not be aware of your company, can you give us a sort of a short potted history of Mobility Insight and a brief introduction to yourself?
Sure. So I'm as you said, I'm from Israel. I'm here in Tel Aviv. Most of my career was building startups, some of which relating to transportation, others relating to big data analytics and simulation-driven decision making. And I've joined Mobi 6 years ago as the VP product. And Mobi, as you can see on the screen, we are addressing one of the challenges of the urban environment, which is gridlocks, and we are attempting to unlock the traffic grid. And we were addressing the three main questions: what is happening on the road network, where is it heading, and what to do about it. Mobi, we have developed a transportation management as a service platform, which is an AI-powered software system that provides policymakers, transportation planners, and traffic controllers with foresight and insight. So we're actually doing descriptive analytics, predictive analytics, and prescriptive analytics in real time, as well as providing the enabling conditions for optimization plans to be developed and actualized and operationalized as the different challenges on the road network arise. The value that today we're bringing to road authorities, both here in Israel and in the US, we have demonstrated already a factor of 8.7 return on investment in terms of operational cost, 30% improvement in level of service of the road network. And since we are adding on top of our management system the ability to optimize the network, not only with the existing tools, such as traffic light signal timing, changes, dissemination of information, and so on, but we're also adding the ability to differentially add congestion zone pricing as a tool to optimize the network. So we're bringing a new revenue stream on top of the ability to take back control over the road network. Okay. We're addressing three segments: those road authorities that today have no system that allows us to have mobility situational awareness and decision and data-driven decision making. We're addressing high demand areas of interest, and as I said, a bankable solution relating to dynamic pricing. Yep. So that's in a nutshell what we.
Question for you, Gadi.
Yeah, sure.
The 8.7 return on investment.
Sure.
Tell me where that came from. Is that a client assessment?
Actually, one of the first sites that we won a tender back in 2017 to provide comprehensive mobility situational awareness for the city of Haifa, which is the city in the northern metropolitan here in Israel. And a study has been commissioned to assess the impact of our system's work on the road network. And this is actually one of the Professor Chaim Avriram from the Technion did that study, and that number is coming from the academic investigation that was put in to understand what such system as ours, and specifically ours, are providing the road authority. And this is, by the way, the 8.7 factor that you're seeing here is relating to direct return on investment. This does not include, for example, improvement in the investment relating to pollution and other sorts.
Okay. Kind of figured that was rigorous because it's precise and conservative. Pretty good.
Correct. Yep. Absolutely.
Good combination. Yeah. On your website, I do like your website. You've got one of those very fast-moving backdrop videos. I like that. It says on your website that Mobi offers smart cities a turnkey, bankable software as a service solution addressing the problem of traffic congestion.
Correct.
Here's the obvious question I'm going to ask. What is a turnkey bankable software as a solution, software as a service solution in this context?
So the turnkey part, I think, relates to two parts of the story or the challenges that road authorities are faced today. First of all, it relates to the three main functionalities they need. What is happening, and this is why we created in TMAS the Mobi Aware part. Where is it going to? Where is it heading? The Mobi Predict, and what to do about it. The Mobi Assist part. We are also already incorporated capabilities relating to connected vehicles. So TMAS is future ready in terms of the transition that we are spearheading, moving from the ability to impact flow of traffic along the network to actually move to discrete vehicle management. And this is something that I think is around the corner. But if you look at today's challenges, it's also that road authorities are faced with. This also includes the understanding of the capabilities and the prioritization of deployment of connected vehicle technologies, because it's not only about safety. It is also about a paradigm shift that we can bring to the table regarding our ability to influence the movement of discrete vehicles in accordance with an optimization plan. So this is something that I think is very unique. So this is one part of the story. The other part of the story relates to the fact that we are starting with the data, moving along to the analytics, and concluding with closing the operational loop with having an impact on the network. So as you can see here regarding the Mobi's product, we have sourcing of different data streams from our own IoT network that provides vehicle trace, vehicle count, vehicle classification, which is the fundamental building blocks for all the performance analytics on top. But we are also fusing in other sides of the parameters that relate to mobility. It's not only about performance, it's also about demand. So we are also ingesting into our system cellular data or mobile app data in order to account for not only for the performance, not only about the impact of what has happened in light of the assigned demand on the network, but also actually the demand itself. Right. So different types of data here are being processed. We have a big data analytics platform that focuses on these two types, these complementing types, the demand and performance regarding descriptive analytics, as well as, by the way, a third dimension relating to transport usage analytics. So it's not only about what is happening on the network, not only about what is the demand or the requirement that for people that want to move from point A to point B, but what are they using in order to mobilize themselves on the network, whether it be private vehicles, car sharing, carpooling, transit, train services, micro mobility, and so on. So these three, this triad, demand, performance, and we will continue to talk about it as we go along this presentation. Performance, demand, and transportation usage analytics provides the unified data set, and this is something that Bob and I composed together, the idea of a unified data set that is an enabler, the fundamental enabler for any analytics to be brought on top, and for new types of insights to be brought to the table. As you can see here, we have actionable insights with predictive, prescriptive, and the idea of a playbook integrated development environment. We all know, whether it be soccer, American football, or basketball, we think about different plays. Each one of them tries to optimize the game differently. The idea, the most fundamental understanding is to understand the different outliers between the different contexts each one of those plays represent, and the ability to actualize, to activate the right plan, the right optimization, or the right mitigation strategy at the right time. So that's the idea here, is not only to provide an engine, the prescriptive analytics engine that chooses a certain specific plan, but also to provide the environment where those plans can be developed. That's that part. And last but not least, we're talking about network impact tools, DMS signs, apps, V2I. That's on the messaging side, adaptive signals with timing and prioritization in the middle, and dynamic pricing at the end. Of course, all the UX and and the control. This actually enables us to orchestrate the entire life cycle of the TMC that incorporates also modeling inside.
Okay.
And regarding your idea, your question about a turnkey solution, that means that everything here in terms of the solution is taken care of, where our decision support system is in the middle and orchestrates the activities around it.
Got you. Okay.
Gadi, I'm in Perpignan in the south of France, and Kevin's in London. If we wanted to access your solution, presumably all we need is an internet connection?
Yeah, absolutely. It's on the web. Everything here is cloud-based. We are certain technologies have computation on the edge, for example. That means that some, if needed, and again, it's always if needed, an IoT network with computation on the edge can be added. We usually do that, by the way, because we understand that the data enhancement is the crucial first step that should be handled. So biases should be corrected, data should be enhanced and processed in order, because if you fuse the data before you do that, it's garbage in and garbage out. The idea is to make sure that the data that we're bringing to the table has been verified, has been validated, has been corrected, and has been, in terms of the topology of the monitoring coverage, has been used at the right place in order to bring the right results. So in that sense, we are indeed a cloud platform. For different calibration methods, sometimes you need to put something on the ground, but most of our data streams are actually not only reliant on actual devices that we put. We can take data from the city, we can bring in third-party data such as cellular, mobile app, and so on. And in that sense, it tilts to the cloud side and to the website, and you just need to flick on the light.
I'm sure Gary's going to cover this, Kevin, but one of the things I really, really like is he has a focus on what I would call performance management on the data using quality. And I found a great quote yesterday from a guy from the 1600s called John Trapp. And I was thinking about the unified data set when I read the quote. It says, "Unity without verity is conspiracy."
Very true.
Nice.
Very
like
true.
That. That's
very
good.
True. Very true.
Yes, sadly, still very true.
Yep.
500 years later. That's a good point. So, but not everybody watching this video will be experts in big data analytics. Could you give those that aren't like a real world example of how what you do has actually made a difference to a city or to an authority or solved a problem? Is there something you can actually
Sure.
show us?
Let me jump to another part of the, so just to say what we're jumping on top. So we have a decision flow chart that shows, by the way, how these different elements in the system are being orchestrated with the DSS in the middle. We have the different data sources that we are using. We covered some of them, but as you can see, there are a lot of data types that have been used in different contexts. And let's move to three highlights regarding where we exemplary sites that our system has proven its capabilities, and this type of big data analytics and insights have been proved valuable to TMCs on the one hand, traffic management centers on the one hand, and to traffic planners on the other. So the first example I want to bring is Atlanta. This is the first site that we penetrated the US market in. We back in 2017, we met Samir Saini, who was the CIO for Atlanta. And as his investigation into new smart city and smart mobility technologies, he noticed our system and our technology, and actually decided to put it to practice in real life. And as such, back in 2017, in August, the Mercedes-Benz Stadium, the new Mercedes-Benz Stadium, was opened. This is in the downtown, and the Mercedes-Benz Stadium hosts the Falcons, which is the football team, and Atlanta United, which is the soccer team, and other concerts. That means that on top of the already hectic traffic dynamics that the downtown Atlanta exhibits, and the huge congestion problems that they have there, that means that every 2 days, since there's the stadium there, by the way, there is also the State Farm Arena, which is the venue for the basketball team, and the Georgia Congress Center, all are in the downtown area. And that means that every other day, something really, large attractors are pulling different types of mobility demand on top of the already hectic traffic dynamics. And this is where actually our system was facilitated in managing that type of data. So our system worked there 24/7, providing real-time analytics to the TMC, and specifically in and around the events that were happening continuously throughout the week in downtown Atlanta. You can see here our TMS. This is the dashboard, the main dashboard that is shown in the TMC. 3 parts, important parts. The dashboard has the left part regarding descriptive analytics. So here we have AI across the board. That means that we are using AI in different manners for different purposes. Regarding the descriptive analytics, we understand that we want to show the controller just what it needs to see just at the right time. So we're not showing everything, because that means that we are just exchanging the eyeballing of monitors on the road to just a whole lot of information. The idea is to understand what is the crucial information, what is the important information that we need to see, what are the different metrics. For example, you can see here flow on the entire network. You can see also this is interchangeable with speed as another metric. This is also can be relates to delay time, such as an index relating to the performance, and that combines actually flow and speed. And other types of indexes, such as the reaching different thresholds at different resolutions, from the network level down to traffic analysis zone, corridors, links, and junctions. So, and you can see here, of course, a graph. At this point, it's on a network level, and the deviation of flow at the network level from the regular day traffic. We deployed there back in 2017. We ran more than 100 large-scale events until we reached the 3rd of February 2019. What you're seeing here is our system working during Super Bowl 53, one of the largest events in the US. I usually joke that just to demonstrate how well the system worked, nobody talked about how bad the traffic was on that day, only how bad the game was. So unlike for example, Super Bowl, the next Super Bowl that was, I think, in Florida, where people stopped they had to stop, they left their cars on the highways and were stuck in a 4.5-hour traffic jams. Nobody talked about traffic jams here in Atlanta, which is a great success to the TMC in Atlanta, which both use our system, but also built very comprehensive optimization plans to deal with different emerging contexts. So this is the descriptive side. The predictive side takes into account, I want to highlight two things. One of them is relating to the fact that we are not only, it's not only about speed. The prevailing metric that TMCs and others use is speed or travel time. This accounts for what, this is too late. This accounts for the impact that is being placed on the network. Once you realize you need to monitor flow, and I'm not talking about volume on sections, but the ability to trace vehicles and understand flow pathways on the network, you understand actually the behavior that causes later on the impact.
Yeah.
That means you may have insight well before a problem becomes something to disseminate, but to actually be able to preempt it. This is why we introduced at that point, and now it's much more comprehensive, but you can see here as an example, two types of predictive alerts that relate to network states.
Mm-hmm.
So if I'm looking at network states, I'm always looking at the pathway, and I'm looking always what is happening downstream from it and what is happening upstream from it. What is it feeding and what is it being fed by? Where our bottlenecks are going to emerge downstream, and where is traffic load builder coming from upstream. So this is how we are addressing the ability to pinpoint, target, and source of different problems on the network from a network state point of view. Looking at things at the network state, not on the link itself, but is what is happening around the link that is important. And may show you what is happening, is going to happen. Last but not least, the prescriptive type side. Here we are activating actually prioritization plans. You can see here specifically different corridors that have been prioritized in light of the analysis of the current and emerging traffic road network condition, and calls for a specific, the idea behind prioritizing that corridor is in light also of an optimization plan that was previously developed. Now that optimization plan does, by the way, because of the natural variance of traffic dynamics is such, the idea when you run a simulation or an optimization plan is specifically to, the most important part is specific to understand what is the context. Then you need to move down to the specifics of that specific, the emerging situation, and adjust that context or adjust that mitigation strategy to the exact current situation. Specifically here, you can see this adjustment being reflected by the different corridors that are being prioritized in accordance with the optimization plan.
Okay.
Now, I've always struggled with the difference between descriptive, prescriptive, and predictive. I've been thinking about a medical analogy. You know, if I go to the doctor, then he will use descriptive analytics to tell me what's wrong with me. And then he'll use predictive analytics to tell me what's likely to happen. And then he'll give me a prescription to solve the problem.
Absolutely. Yeah. A remedy, a recommendation, absolutely.
Yes, good,
yes.
Excellent.
Sure. Can I ask a question in terms of people? What level of staff in Atlanta use this information?
So in Atlanta, there was Samir Saini, the CIO, and his directors that used it in order to understand strategically, right? I think that again, I think that the different levels are if you look, for example, from the strategic point of view, you want to have, besides mobility situational awareness at large regarding the network, you want to understand, to evaluate different courses of action for enhancement of the network or for the road network, to build more, I don't know, to change something in the signal timing and so on and so forth. That's the planning side. But in terms of strategy, it's about budget allocation. So at the level of the CIO, it was first and foremost about the ability to report on the condition of the network. But the second place is the idea of taking into consideration the dynamics that are occurring on the network, the different contexts that are being addressed in terms of budget allocation. And last but not least, in terms of impact assessment, are we getting better or are we getting worse? So that's crucial when you want to run projects at that level. The second level was the planning. So that was the different planners that developed optimization plans. And suddenly, what you're seeing here on the dashboard is the IDE part, the playbook IDE part, that environment that we provide the different analytics to developers. This composed of, as I said, performance, demand, and transportation usage. Everything the planner needs. So here we had our IoT network providing vehicle trace, count, and classification. We had Verizon data allowing to understand demand. We had we brought in data from the city, from cameras and so on, in order to weigh samples in order to represent the entire population. We brought actually on different occasions other transportation modes. We brought in MARTA data, which is the train services, all of which provide us with a complete understanding of mobility on the downtown area, and this was accessible by the planners. And last but not least, the operators, the controllers that ran this system in real time in order to mitigate different problems.
So multi-level staff, that's the
correct.
Correct. Bob, I interrupted you, Bob. I apologize. You had a question and I cut you off.
Must be getting old, Kevin. I can't remember the question.
Well, let me ask another one then. I'll ask another one that might maybe spur your memory back.
Now the question is, was that a predictive, prescriptive, or a descriptive analytic right there?
I'm not sure.
I just wanted to make sure we understood the difference, because they all end in IVE. So I just wanted to kind of
correct.
What we need, Bob, is a Venn diagram, and the intersection you appear in, that's where your question will appear. So in terms of
can we make it animated as well?
Yeah. So in terms of, we'll just use Atlanta. You got the same results from Tel Aviv. Let's look at Atlanta. How did the city of Atlanta integrate the analytics into, let's call them, their existing business processes? Because it's not like a plug and play thing. It's a simple thing. It has to be something that's sort of intrinsically and learned, and everything works together perfectly. How do you make sure they do that in the right way?
So I think that the learning approach, or the learning regimen that was in place in the TMC in Atlanta, I think was pretty remarkable, because different processes were running. It's not only about our technological system. It's not about the development of different optimization plans, which is addressing different contexts. It's the using not only the system in real time, but diving into the BI itself that is also being provided by the system, and looking at different automated, both custom and canned custom reports that the system automatically provides, and just actually studying that, right? So on the fundamental level, it's all about the learning TMC. Right? We were always talking about smart city. What does a smart city mean? It means actually this: the ability to continuously reframe the way that we are looking at different contexts and provide different solutions to emerging trends. I think that's crucial in terms of the modus operandi of a TMC. But in terms of technology, again, our system is very open. In Atlanta, for example, this system was used side by side with other systems that allowed for monitoring, actually seeing different cameras. In Tel Aviv, for example, I can tell you that our insights were being fused into an already in place ATMS. So different configurations can be, but I think that the API is the easy task. I think because it's much more fundamental than that, is how the different processes are being impacted. And I think the idea here is to address each one of those processes, to provide it, to facilitate the life cycle of the different processes of the TMC and the planners, policymakers, in a way that they'll feel the value that is being brought to the table. Yep.
Kevin, when I started looking at smart cities and smart mobility, I realized that there really wasn't an accepted global definition of a smart city. So I actually came up with my own definition, which is, you live in a smart city if you poke it with a stick and it reacts appropriately. And that's really what Gadi is saying. A smart city has sensors. It can understand the variations in demand. It can understand the variations in operating conditions, but also has the intelligence to take the appropriate action.
Correct. I would even emphasize, I think you're absolutely on the mark. I would even emphasize something that I think that some cities miss. It's not about data-driven decision making, because there is a lot of data out there. The idea is, how do you make sense out of it?
Right.
Okay.
Right.
And this is why, and this again goes into something we'll talk about later on. It's about the performance measures. It's about how you understand what is the different axes that are being used in order to understand what is indeed happening on the network. You can call it performance measures, KPIs, whatever, what have you. But the idea is, it's not only about the data, but the framework for understanding or analyzing that data which is being fused in. More data does not necessarily mean more understanding. And from my experience, cities come to us time and time again, said, look, we have data. So maybe we're not correct, we're not processing it as good as we can, but what do we make of it? And I think this is where Bob's point regarding the reaction of the smart city comes into play, because it needs to keep on reacting. The fact that you
We briefly lost Gadi there. Have you lost Gadi as well, Bob?
Yep, he's frozen in time.
He has frozen in time.
made a survey back in 2011. Definition, it's by definition out of date. And we're actually it's here in Israel, in the US, we have the same, we're suffering from the same problems in terms of surveys, census data, and so on. It's mostly out of date, and that says something about our plans. And this is why real time on the one hand and continuous data streams on the other, analytics on the other, I think play a major role in the next generation traffic management systems.
Okay.
Just to by the way, to complement this side and to introduce another example, we have actually, we are within we have won another tender here in Israel for the demand analytics for the Ministry of Transport for the entire state of Israel. And this means exactly, this points at the exact point that I just made. The idea of an OD matrix that reflects number of trips, kilometrage, overall travel time from origin to destination, which can later be assigned in simulations and run, and on top of which you can run optimization plans. This is something that is crucial in terms of understanding traffic dynamics, because it looks at the reason. Why is the network is performing the way it does? Because first and foremost, because demand has been exhibiting a certain condition or behavior or profile. So the idea of having patterns that are up to date regarding the OD matrix that have different resolutions. For example, here in Israel, we had 4 resolutions at the metro level and down to the 2x2 block level for traffic analysis zones. And for each one, we had both daily and hourly OD matrices continuously being developed. And moreover, for each TAS, for each traffic analysis zone, it's not only about the movement, but who are the travelers? that are in those traffic analysis zones. Are there commuters? Are there residents? Are there visitors? So the idea of profiles regarding the distribution of types within traffic analysis zone also is super interesting. And of course, as I mentioned, it's not only about the patterns, but the continuous development or updating of those patterns to reflect current conditions in different contexts. Different demand profiles show different contexts, of course, or reflect different contexts, and should be, so you can say, okay, this is a weekday, this is a weekend, but you can also say this is a weekday with rain or with snow or with black ice, and so on. So this is just another example of the demand side of the story.
And to me, this level of insight is a prerequisite for an effective road user charging program. You first of all need to understand how things work before you try to adjust it.
Correct.
You know, first of all, this lends itself to a pilot or an early winner where you can actually find out what you're really going to use the data before you scale it up. I feel bad for data kleptomaniacs everywhere now, though, because you're taking the fun away, Gadi. You know, previously I would collect every piece of data to the highest possible accuracy and submerge myself in it to the point where I can't use it.
Yeah,
correct.
You know, you're taking the fun away and making it scientific and results driven, man.
Sorry about that.
So I can hear the sound of all these kleptomaniacs getting on a train and leaving the smart city.
Yeah,
and of course, Kevin, how did we get them on the train in the first place? We enticed them with data.
And free coffee.
So
data and free coffee. It does work.
Correct.
So let me tell you why I like Gadi and why I like Mobility Insights, right? They're not vaporware. They're not talking about what could be in the future. They've developed a product.
Yeah.
Right? They've engaged the market. They've developed a huge expertise and capability, a body of knowledge, if you like, in analytics applied to transportation. And I think that combination is very important because I think what we're explaining here in this video is this is why you should be interested in big data, why you shouldn't be afraid of it. You should be grappling with analytics, and it's compelling the way Gadi puts it. And you're going to get new insights, new understanding, and do things better. And to me, that's what this is all about. So I applaud Mobility Insights for developing this, but not just kind of throwing it over the wall as a product, but working with the product and developing a complementary expertise.
Yep.
Thanks, Bob.
It's a way forward, but it's in terms of usability. People want to see, okay, that's the product, or how do I use it, or who's used it before? What's
right?
You know, you've taken all that mystery away. But again, maybe that's a shame. But there's no mystery involved anymore. Of like, oh, will this work? You know, it's going to work.
There are other mysteries, Kevin. There are other mysteries.
Oh, that's very true. Yes. Here's a good mystery. Why do heat waves not have a name? Storms, hurricanes, tornadoes all have names. Heat waves don't have names. I think the next heat wave we should start with A. Heat wave.
I second that.
But Gadi, thank you very much indeed for your time.
Thank you.
Hopefully, everyone watching this, you've learned something. I certainly have. If you want to know more about what Gadi and his team do, it's mobilityinsight.net is the website. I'm sure there are ways of getting in touch with Gadi on there with frequently asked questions, or I'm sure there's email addresses, and you can find out a bit more into how Mobility Insights project, or Mobi's projects and solutions are going to suit you and solve your problems. So Gadi, thank you very much indeed. Bob,
thank you.
Thank you.
Thank you. And Kevin and I will be back with the next one on road user charging with the sound of it. I think you teed that one up there, Kevin.
I think we have. I think we've done that. We've segued beautifully into part 2. So this is our first Smart Mobility video masterclass. Join us again for our second one very soon. And thank you for watching. Goodbye.